Welcome, everyone. You are watching my YouTube channel Learning Statistics with Dr. Zayed. In this lecture, we will discuss the acceptance-rejection method for random number generation. This method allows us to generate random values using simple mathematical ideas. Let us begin by understanding the objective of this lecture. Our objective is to generate random numbers from a target distribution. In other words, we want to simulate values from a function that represents real-world behavior. However, this leads us to an important challenge. The problem is that direct sampling from the target function, which we call f of x, is often difficult or computationally expensive. Therefore, we need a smarter and more efficient method. This brings us to the basic idea behind the acceptance-rejection method. The key idea is to use another distribution called g of x, which is easy to generate from. We then choose a constant c, such that c times g of x always covers f of x for all values of x. In this way, we create a boundary around the target distribution. To understand this better, let us look at a visual interpretation. Here, f of x is a target distribution that we want to simulate. G of x is a proposal distribution, which is easy to generate. And c times g of x acts as an envelope that completely covers f of x. You can think of this as placing a cover over the target curve. Based on this idea, we can now describe the algorithm. The acceptance-rejection method consists of three main steps. First, we generate a value from the proposal distribution. Second, we generate a uniform random number between 0 and 1. Third, we perform an acceptance test. Let us now go through these steps one by one with an example, but first we talk about c. The probability of accepting a value x is equal to f of x divided by c times g of x. This acceptance probability guarantees that the accepted samples follow the target distribution exactly. Now, an important question is how efficient this method is. The efficiency of the method depends on the value of 1 divided by c. This represents the acceptance rate, or the proportion of values that are accepted. A smaller value of c gives a higher acceptance rate, making the method more efficient. Always choose c such that it should cover the base distribution f of x. Let us apply this method on simple example to understand this procedure. In this example, the target distribution is a linear increasing function. Target distribution is one where we want to draw random samples. Although it is simple form, but we are assuming that it is in complicated form just for understanding purpose. The proposal distribution is uniform between 0 and 1. The maximum value of the target function is 2, so we set c equal to 2. This ensures that the envelope function fully covers the target distribution. Now, we can apply the acceptance rule in practice. In this case, the acceptance condition simplifies to u is less than or equal to x. For example, if x is 0.4 and u is 0.7, we reject the value because u is larger. If x is 0.9 and u is 0.3, we accept the value because u is smaller. This demonstrates how the method works step by step. Now, let us see how to implement this in R. This slide shows our code for implementing the acceptance-rejection method. We repeatedly generate values of x and u and apply the acceptance condition. We continue this process until we obtain the desired number of samples. Finally, we plot a histogram of the generated values and compare it with the true function, which is 2 times x. This confirms that our method works correctly. You can try this example yourself in R. If you need this code, let me know in the comment box. Thank you for watching Dr. Zayed's channel for learning statistical methods. If you have any questions, please feel free to ask in the comments below. Stay connected for more lectures on probability and statistics.